Hey everybody, we're going to be taking a look at this circuit here and trying to find VA, VB, VC, and I1 using nodal analysis. So let's take a look. We got our circuit here, and let's try to find VB first. So, well, actually, we already know VA. If you look at it, VA is right above the battery of 10 volts, so that means, and there's nothing else really going, there's no other source going there, so VA has to be 10. So cool, we already got the first part right. Now let's find VB. So, since I is equal to V over R, where nodal analysis involves current, where all the current at that node is equal to 0. So, at node B, this is where VB is, we know that the voltage difference, so VB minus VA over that 1 kilo ohm resistor is the current coming to VB. Then the current leaving VB is VB over 2, because that 2 kilo ohm resistor there, 2 kilo ohm resistor. And then we also have the 4 milliamp current leaving. Since we're just looking for I, that's I. So all that equals 0. Remember, all the current at a single node is 0. So summing those up, and we know VA is now 10, so we can just plug that in. And just, doing some algebra here, we can solve for VB. So divide by that fraction of both sides and you get VB is 4 volts. Check it out. Awesome. Good work. That's nodal analysis part 1. Here's part 2. So now we're going to find VC. So looking at VC there, that's node C. Same thing. The current going at that point is exactly 0. So let's see where all the current is coming from. Well, we have the negative 4 amps coming in, right, at VC. Then what's leaving? Well, what's leaving is VC over 4. The current's going down the 4 kilo ohm resistor in that direction, so it's leaving, it's positive, over the 4 kilo ohms. And then plus, we also have VC minus VA. So since we have VA and we know it's more right, like even if we messed up on B, we know VA is definitely right because that's pretty simple. It's almost a given. We know that if you follow that current, you'll be going through that 4 kilo ohm resistor as well to get to VA. So the voltage, that current, is given by VC minus VA over 4. And all that has to be equal 0. Again, doing your algebra, you know VA is 10, so we plug that in, get VC out there, and divide by the fractions, and simplify, and we get VC is 13 volts. Nice. Next, we're going to try to find I1, and we're just going to do a loop around that lower base there for node A. So I1 would be equal to VA, right, minus VB over 1. So we have the current from A to B there over the 1 kilo ohm resistor. We know what that current is now because I equals V over R. And then we're going to add that the difference between VA and VC, because we're going to go farther there, over that 4 kilo ohm resistor, and that'll loop all the way around back to VA, where we have our I1 coming out. So just do some math there. VA is 10, and you get I1 is 5.25 milliamps. Awesome possum. I hope this was a good example for nodal analysis. Remember, nodal analysis is about current, and current at a node is 0. You write the equations, and then you can solve. Great job.